Hello, clever members and everybody watching. Today we have a code that I did, a big project that I did for the internship Clever Google Colab Python, and it's called Loay's Talk to Speech project. App user and I named it App User Manual Hertz Spectrometer, and it has gTTs in the output. About me. I am Loay. I'm 17. I'm working on my career and I am in senior year, and hopefully the code works when you run it twice. About my internship, before we start the code, I just want to talk about the internship with Clevered. I've made a lot of interactions with Clevered. With Clevered, one of them is this advanced short AI internship. With Clever, I have learned five developer levels. How do I use the app? How does the project work? For example, you should acknowledge that you should allow mic access, and you should run the code twice, because it can be, you can run it only one time, but if you're not using Google Colab, if you're using Google Colab, you should run the code twice, and it has the user interference, so it's up to you. Example, changing the duration of the recording and changing the languages that you use. You can change any language you like. As I said, you use the talk to speech in the output and prints it out, calculates the hertz of your normal male female voice, and hopefully the code works when you run it twice. Let's see how the code works. So first, as you can see, I'm using Google. I'm using Google Colab, and I used Python and a little bit of JavaScript. As you can see here, uh, um, everything is like quite simple. Here's like the plot spectrum, and the main thing of the code is to find the dominant frequency and the plot spectrum. And here's the JavaScript code that I used: output register callback, handle audio, define, yeah. And that's like pretty much the only JavaScript that I used, and we should run it. So as you can see, it like prints that you should speak, like as you can see here. Let's run it. I ran it before, and here's the audio waveform, and here's the spectrum dominant, and the output, like sometimes it picks up the output 570 hertz, and it's like it sometimes picks up what I said. Okay, let's run the code twice or once. I ran it before, but let's run it again. Okay. So here it's downloading the data, and it should take some time, like 30 seconds or so. It took 15 seconds, and here, as you can see, I have the user interference GUI, and here's the duration. I like it like 4 or 5 seconds. It makes it more accurate, and I only speak English from one of these languages. And let's press record, and here it says that you should allow the mic access, and now we should run it again. Now we press record. Test. This is here. The recording is started. Test. 1 2 3. Test 1 2 3. Recording stopped. As you can see, the recording is stopped. And here should be the output.
Best this is here the recording started test 1
As you
2
can
3
see,
test.
as you can see, it picked up my voice, but a little bit.
Test.
Here's my voice.
Here, the recording started. Test.
Here it picked up my voice before I pressed OK. And here's the audio waveform. And here's the spectrum dominant. It says that my voice is 150 hertz. And here's the output of what I said. This is the recording started. Test. It's like fast when the TTS speaks. I don't know why, but it's fast. And the dominant frequency is 150 hertz. And a small vote of thanks for all who have helped me in this journey at development. My parents and my mom and my dad pushed me so much. Mr. Ken and Clever and mentors, they were with me in this journey, and the group members and friends and the sites that I used, like Google Colab. And here just forget about that. Here, contact me. Like, if you have anything wrong with the code, you should reach out to me. Please reach out to student me, Loay Hosam Hamamsy, and I hope this code works well. And yes, I think that this was a success, and I trained so much, and I thought about making this code, this project, and hopefully we see you in the next project.